Hello guys, this is part 15 of our 8086 programming tutorial. In this part of the video, we are going to write a program to display the content of a 16-bit signed number in decimal format on the screen. Now see, if I remove this word signed from this question, then that problem we already have solved in part 14. Isn't it? So in part 14, we wrote this program, display the content of a 16-bit register in decimal format on the screen. And if you remember that the part 14 video, towards the end of the video, I showed you what happens when we store a negative number in, like when we pass a negative number as an input to the program, and we saw that the output generated is wrong actually. It doesn't produce the right output for negative numbers. So that program that we wrote in part 14, that was only for positive numbers. So that program was not working right in for negative numbers, and that problem we are going to address in this part of the video. It means what? So for example, we store minus 90 in AX register, and then we print the content of this AX on the screen. So that time what we want to see on the screen, we want to see on the screen the string containing the three characters minus 9 and 0 on the screen. Isn't it? That is, we want to display this number as it is along with its sign on the screen. Now, to do that thing, we need to know a few details actually. So, well, only a few details actually, and maybe one or two new instructions, simple instructions certainly. So, the first thing that you need to know is how these negative numbers are stored in the memory. So for example, what I mean is, for example, you consider, say you write an instruction like move AH, say for example, AH comma 5H. So in this case, if I ask you what is the content of AH register, you will be saying directly in 8 bits, it will be 4 plus 1. That is these are the least order 8 bits or the least order nibble, and the higher order nibble will be 0, 0, 0, 0. So this is 5H in 8 bits representation, isn't it? Yeah. Then if I ask you then the question like move AH comma minus 5H, then what is going to be stored in AH register? Okay. Now to answer that question, what you need to know is that these negative numbers, they are stored in 2's complement format, and what does that mean actually? Okay, this is the statement actually, negative numbers are stored in 2's complement format, and how it is actually, okay, what is this 2's complement format, or how we compute the the 2's complement representation of a negative number? That is the question now, right? So how it is computed actually? First thing is that how to compute 2's complement. I'm writing 2's C representation, 2's complement representation of a negative number. So that is the question then, right? And how to do that? So to do that thing, the first thing that you have to do is, in a part, what you have to do is you have to get the binary of the unsigned number. It means what? When suppose we are trying to get the 2's complement of this minus 5, then what we have to do is we have to get the binary of the unsigned number. It is binary of the unsigned 5. That is, we only have to get the binary of 5. So we already know what is the binary of 5: 0, 0, 0, 0, 0, 1, 0, 1. In 8 bits, this is the binary of 5. Okay, that is done. The step 1 is done. And in step B, what you have to do is you have to take the 2's complement. Take 2's complement of that binary. It means what? 2's complement, how it is computed? Again, first we have to flip the bits, or we have to take the 1's complement. So it will be 0, 0, 0, 0, 0, 1, 0, 1 will become in 1's complement 1, 1, 1, 1, 1010. That is 1's complement, and then we'll be adding 1 to it to get the 2's complement. It will be 1101, and this 1111 will be as it is. So this number, whatever the binary sequence you get, that is actually the 2's complement representation of the negative number. So in this case, it is this specific binary sequence is the 2's complement representation of -5h, and that sequence, this binary representation, will be stored in AH register. In AH, what will be stored? 11111011. So it will be stored like 11111011. Okay, that's okay. Okay, if you have understood that point, then the next question is, say, so what point we have understood? We have understood like negative numbers are stored in 2's complement format. That we have understood, right? Then the next question is, like, say, how do we know? Let me use it a different color for a change. Then, so given a bit pattern, now next question is actually given a binary number or a bit pattern, how to interpret it as a signed number. What is my point is, you see here the content of this AH register here, the content of this AH register. Let me copy it and let me paste it here. You see the, where did I paste? You see the, just a second, just sorry for the inconvenience. Yes, you see the content of this AH register now. It is 000001. In one case it is this, and in another case it is this. Now how, suppose if I say you, what is the value of AH register? If I simply ask you what is the value of AH register, then you will be saying, okay, in this case the value is, there is no doubt here, in this case the value is 5. But in this case, what is the value of AH register? Now it is actually a question of interpretation. Should I now consider this AH as a signed number, or should I consider it as an unsigned number? Because you see here, if it is a signed number, then certainly we know, because this representation we got from -5, so certainly somehow we have to get this number as -5 if we consider it as a signed number. But if we consider it as a unsigned number, then certainly what will be the value here? The value will be, it is see here, 2 to the power, you just see here, 11111011, 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3, 2 to the power 4, 5, 6, and 7. So here it is 1, 2, 8, and these are all like 16, 32, 64, and then 128. So if you add them up, whatever it is actually what? 255 minus, I guess, 4. So it will be 251. So 251. So if you consider this number, let me confirm it using this calculator. We have it, right? So what is the decimal number we want in binary? No, we want, okay, they said convert it, 251, convert it, see, 11111011. That is the decimal number, 11111011, 11111011. So 251, right? Now see, what my point is that in this case, there is no confusion. If I ask you what is the binary, what is the, what is the value which is stored here in AH, directly it is 5, only one representation. But what if, what is this number now? If that number is to be treated as a signed number, then certainly we have to get -5 from it somehow. And if the number is considered as an unsigned number, then we know, like, we are going to get the value of this AH register is 251. So what is the point here is that whether you consider the number as signed or unsigned, based on that, the value might change. Now say my question is, given a binary number, how to interpret if it is now how to interpret it as a signed number. It means what is the value of that binary sequence if we consider that binary sequence as a negative number. See, if we consider sorry, as a signed number, okay, so if we consider that binary sequence as an unsigned number, then it is straightforward. You just have to, add the powers of these two wherever there are these ones in, in the binary sequence, right? So that way you can compute if the compute the value if the sequence is to be treated as unsigned number. But if it is to be treated as signed number, then how we are going to interpret the value? That is the question. Okay, it means how, the point is now more specifically, how from these binary representation we are going to get this -5. So that is the thing actually. Okay, so to do that, the first thing is that whatever the number it is given, it could be in it should be consistent with both these, in both the sequences of this type or this type. Okay, now let's say for example the pattern which is given to us is 1 1 1 1 1 0 1 1. Now you have to remember, in signed representation, that is if you are interpreting a binary sequence in signed format, then what you have to do is you have to consider the most significant bit as a signed bit. This is signed bit. The most significant bit as a signed bit. Okay. Now see, if it is 8-bit register, then the most significant bit will be the 7th position. If it is a 16-bit register, then the most significant bit will be at 15th position. That is, for 8-bit register, signed bit is the 7th bit, or 16-bit register, signed bit will be the 15th bit. Clear? Clear. So what we want to do is, first thing is that if we are trying to interpret the number as a signed number, then first thing that we have to look at is the most significant bit of that binary number. If that most significant bit is 1, if it is 1, then that is, if most significant bit is 1, most significant bit is 1, then this implies it's a negative number. Okay, and we have to like interpret that number in a different way. However, if the most significant bit is 0, then that number is a positive number. Okay, and in that case the value of the number is directly the value, then the direct value. Okay, we do not have to convert anything, direct value. So let's first see the easy case. The most significant bit is 0. It means it's a positive number, and the value is the direct value. What I mean by this is, say for example, if I ask you what is the value of AH register if you treat this binary sequence as a signed number. Okay, so in that case, what you will do, what we will look at is the most significant bit. Since it is 0, you know that it is a positive number, and that is why whatever these bit sequence is, whatever the decimal equivalent of this bit sequence directly, that will be the value. So in this case it is 5. You got this point? This is the easy option, the easier part. And a slightly difficult part is this negative number. That is, what if now here, say for example, now the AH which is given to you is this, and then we have to interpret like, okay, what is the signed number? Like, what will be the value if we treat this binary number as a signed number? So in the case, first we'll be looking at this most significant bit, which is 1. That means it's a negative number. Okay, we know that thing. Now, if it is a negative number, then what we have to do is, what is the value? Here the value will be the 2's complement of the number, 2's complement of the number, or of the binary number. Okay, so in this case, what will be the value of AH register? 2's complement of this binary number. And what is the 2's complement of this binary sequence? See, the binary sequence is 1 1 1 1 1 0 1 1. So how do we compute 2's complement? First, we flip the bits to get 1's complement. So 0 0 0 0 0 1 0 0. And then we add 1 to it to get 2's complement. So 1, then 1 plus 0 is 1, then 0, then 1, then 0, then 0 0 0 0. So this will be the value of the register with negative sign. That is, now what is the value if we treat this number as, like, if we have to interpret this binary sequence as a signed number, what value will come up with? So we'll first look at, okay, the most significant bit 1, so it means it's a negative number, and its value will be the 2's complement of this binary sequence, so which is nothing but 4 plus 1 is equal to 5. So it means what value is stored here? What is the value of this AH register? -5. You got the point? Now, see, one thing you have to remember or realize is that the it is actually interpretation dependent. I mean, how do you interpret the binary sequence? Based on that, only the value changes. Okay, so both of these values are right actually. I mean, if I say AH is equal to 11111011, then someone might say it is -5. Someone might say it is 251. Both of them are right in the sense that in what from what perspective they are saying the value. If they are like considering the bit sequence as signed number, then certainly it is -5. If they are considering the bit sequence as unsigned number, then certainly it is 251. Okay, so this is the point we need to know now. Now, given a binary number, how to interpret it as a signed number? So if it is the question, like, given this binary format, binary number, we are asked, like, what is the signed value of that particular binary sequence? To do that, first thing we have to do is we have to look at the most significant bit. If it is 1, then we have to take the 2's complement of the number, and whatever it is, negative of means minus that is the result. Say, for example, in this case, -5 is the result. And if it is 0, then it is directly the value, whatever it is. Understood? Okay, let me ask you a few questions just to confirm what we learned. We know that thing properly. So, for example, I ask you, if I store in AH register, for simplicity, in AH register, say the bit sequence is stored in in this way: 10100001. Okay, so this is the bit sequence in AH, say. Now, what is the signed value? What is the signed value? So how do you know what is the signed value there? The first thing is the most significant bit. The first thing that you have to do is you have to look at this most significant bit. So MSB here, it is 1. This implies the number will be a negative number. And then what will be the value? The value will be the 2's complement of complement of the binary number. It means the binary number is 10100001. 2's complement, 1's complement will be 01011110, and then add 1 1 1 1 1 1 0 1 0. So whatever this number is, that is actually the value of that particular number. Okay, and what is this value? This value is okay, that is 2 to the power. Okay, that's 1, that's 2, that's 4, that's 8, that's 16, 32 is missing, and then that's, am I doing a mistake? Then 64. Okay, to the power 0, to the power 1, to the power 2, to the power 3, to the power 4, to the power 5, to the power 6. So whatever all these, if you add them up, whatever it is that you get, that is the number. So 64 plus 16 plus, okay, let me do it. 8 plus 4, 12, plus 2, 14, plus 1, 15, 15 into 15, 15 into 2, 30, 31, plus 64 is equal to 95. So 95, that is the value. So ultimately, what value it is stored there is -95. Okay, so let's see what is the binary equivalent of -95 here in this calculator. Decimal, I just write -95 and I convert. See, binary signed 2's complement, the number will be, it is written in 16-bit, but if you see the 8 bits, then these are first 4, then 6, 7, 8. Okay, 1 2 3 4 5 6 7 8. So 10100001, that is actually -95. Okay, so here 10100001 is -95. Got the point? So now what you learned is you have to actually, like, so then the next question is, then how do you decide whether the number is a signed number or unsigned number? Yeah, it is very simple. Only thing that you have to look is, you just have to look at the look at the most significant bit of the number, and if it is 1, then it's a negative, otherwise it's a positive number. And then if you have to get the value of that number, you just have to take the 2's complement of the given binary sequence. Okay. Okay, let's first write a simple program like to decide whether the given number is positive or negative based on this concept. And then uh, on the top of that, we'll try to write the program to display negative numbers on the screen. Okay. Okay. So, okay, let's start writing it. First, let me show you a few things. Move ax comma data dx comma ax. Now, let me show you. Say, for example, move. I store in ax register the number, say -5. Okay, ax register the number, say 5. I store 5h, and then in bx register I store -5h. Okay, -5h, and I want to see what will be stored in AX and what will be the bit pattern of AX and what will be the bit pattern of BX, or what will be stored in AX, what will be stored in BX. Okay, let's first compile and execute this program in debug mode and confirm. I'll be compiling first tasm pp17.asm, and then I will be linking the link pp17 and then pp17. Now the program is in debug mode. Let's see the our goal is we want to see the content of the AX register and BX register after copying the values. So these values are immediately, although we have written here it in decimal format, they are coming here in hexadecimal, and they are these are the values. But let's see first what data gets stored in these registers first. Okay, first the instruction, second is this, the third instruction is move ax comma 5h. So directly in ax register here, this instruction will store 5 will be stored. But here after that we're storing -5h in bx. So this -5h is represented as FFFB. Okay, you see here why -5h is FFFB. So we have this -5h. Okay, so what is the binary equivalent of -5? So it will be first 5. 4 plus 1 is equal to 5. Sorry, 4 plus 1 is equal to 5, and then 0, 0, 0, 0. So I'm writing here it in 8-bit representation, but all of them are like, these are all 4 zeros and 4 zeros. Okay, then we have to convert it to ones complement. So it will be 1, 1, 1, 1, 1, 0, 1, 1. Sorry, 1, 0, 1, 0, 1, 0, 1, 0, and then add 1. So it will be 1, 1, 0, 1, 1, 1, 1, 1. In hexadecimal, what it will be? It is the 8 plus 2, 10 plus 1, 11. 11 means B, and then these are F. So similarly, all these were zeros and zeros, so they will be immediately converted to F and F. So ultimately, what will be stored? F, 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 B. I mean, F, 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 B is -5h in 16 bits representation. Okay, so that is why this number here this FFFB is copied to BX register when we actually stored -5 in BX. Okay, so that way if I press F7, then you'll be seeing, okay, FFFB is actually stored in the BX register. Got it? So one point is clear that, okay, the numbers are stored in twos, the negative numbers are stored in twos complement format. I mean, if you now want to like verify whether a number is positive or not, or if you want to treat a number as a signed number and then want to know whether it is a positive number or negative number, what you have to do is you just have to look at the most significant bit of that number and you will come to know whether it is a positive or negative number. Okay, then it is, I just said that you just have to look at the most significant, bit. Yes, if we write down the binary representation of the number, then looking at the most significant bit and knowing whether it is a 1 or 0, it is okay, quite straightforward. But what if we have to decide that thing programmatically? Right? We have to decide whether it is 1 or 0 at the most significant bit programmatically. And how do we do that? And to do that thing, one instruction you need to know, and that instruction is shift left instruction. Okay, this instruction is read as SHIFT, shift left. As the name itself indicates, what does it do is it it shifts the okay, let me write it. It shifts the bit pattern, whatever the operand you specify. It shifts this entire bit pattern. This entire thing will be shifted by a specified number of bit position. Okay, let me write it then. It shifts the operand or the source, okay, operand or source, by a specified number of bit position towards left. Okay, and then another thing is that the most significant bit occupies the carry flag. You remember, this is important, huh? The carry flag will be occupied in most significant bit. Okay, what does that mean actually? Now that means is, say for example, you just consider the number is say a 8-bit number. Okay, say for example AX comma 5 8s, we store in AX 5 8s. Okay, so in that case, what will be stored in sorry, AH register? Okay, I don't want to write all these zeros. AH comma 5 8. So here this pattern will be 0 0 0 0, then 0 1 0 1. This is your 5 in 8 bits, right? So this is your bit pattern, and then you have to consider carry flag here. Okay, sorry, not here. This is a bit pattern, and then this is the slot for carry flag. Okay, now when you write, say for example, when you write left sorry, shift left, then by shift left, then two things you have to specify. Shift is the operand or the source by a specified number. So two things. One is, what is it, or what is the source? Our source here is a H register, and by how many bits you want to shift it towards the left. Okay, that is, I'm writing here, say for example 1 bit. So in that case, what will happen is this entire bit sequence will be shifted left, left by 1 bit position. It means what will happen is, actually you can think it of as if this entire bit sequence will be now shifted towards left by 1 bit position. Okay, now when you do that, this bit, whatever it is going out, whatever it is going out of the number, that bit will be stored in CF flag, and whatever it is the empty slot created there, a 0 will automatically come. Okay, a 0 will automatically come. Got the point? We just have to shift now by as many times you want, you can do it. If you want to shift this entire pattern by 5 position, then you can write here shift left of that particular source by that many bits towards the left hand side. But here in our case, here, see here, you should see an opportunity here. See what this shift left instruction allows you to do is, it allows you to shift the content of a register towards left by 1 position. And also, whatever it is the bit that goes out of the number, the most significant bit actually, that gets stored in the carry flag. Okay, so it means what we can do is, say for example, if we do something like this, say we do not know what is there in AH register, say. Okay, so we just do this thing, say shift left AX register by 1 position. If we do this thing, we know one thing for sure, is that whatever it is the carry flag, that will contain the most significant bit of AX. Whatever it was there at the most significant bit of AX register, that will now go to the carry flag. Right, and we know how to check the carry flag. You can use this instruction, jump on carry or jump on not carry. It means jump on carry means when carry flag equal to 0, and sorry, carry flag equal to 1, and jump on not carry means when carry flag equal to 0. So what you can do using shift left instruction is that you can bring the most significant bit of that particular register to the carry flag. Once it is in the carry flag, then you can use any of these conditional jump instruction to check the value of the carry flag, and accordingly you can execute different blocks of code. right? Now that is how we can decide actually. So whenever it is a bit pattern, it is given to us and we want to know in signed representation whether it is a positive or negative number, we just have to shift the register or shift the content towards the left by one position, so that the most significant bit goes to the carry flag, and after that we can verify the carry flag to decide whether it is positive or negative number. Understood? Okay. If it is the case, then let's write this program. Like we want to write a program. If it is positive, it will display positive. If it is negative, it will display negative on the screen. Okay. Okay. So for that reason, we want to display two outputs. So we'll be following our usual trick. So we'll be declaring two strings, string one, db, and say it is for positive number. So we are writing a program that displays if the number is positive, it will display positive. If the number is negative, it will display negative on the screen. Okay. So that's what we're doing. Say negative. The number is, if the number is negative, then we want to display this str2 on the screen. Okay, done. And then say we store the number. First, let me store the number in a variable. Say num db or dw, 16-bit number you consider, and you store the number, whatever it is, 89, 897. And then what we want to do is we want to verify whether that number is positive or negative. So for that reason, what we'll be doing is first we'll be copying that number to AX register, and then we will be shifting this AX register towards left by 1-bit position. And after that, we'll be checking the carry flag. If there is a carry, it means what? The number is negative. So we'll be saying the number is negative. And if there is no carry, then the number is positive. So in that case, what we can do is we can consider it as the else part. So load the effective address in the X register of string. See, for positive, we want to display string one of string one, and then we have to store these 09 in a H register, and done. Done means this. So it will display if the number is positive. Okay, and then after that, jump to terminate. But if the number is negative, then we have to write the code. So if the number is negative, then also more or less the same thing we want to do with this change here. Okay, we'll be displaying string 2 and then we'll be terminating. Okay, so this is the program to check if the number is positive or negative from its bit representation or binary representation. So what we do is first we copy the number to AX, shift the number towards left by 1 bit, then check the carry flag. Why we want to check the carry flag here? Because we know that when we shift the number towards left by 1 bit, then the most significant bit will go to the carry flag bit. Okay, so for that reason, we want to check whether the carry flag is set or not. That is, if carry flag is equal to 1, it means we have to display the number as negative number. If carry flag is not equal to 1, this line will be skipped, and from here to here it will be executed. But this line, again, once the control now displays this string on the screen and then comes here, immediately from here it will jump to terminate the program. So that way, this program will display whatever the number we store here based on the sign of the number. If it is a positive number, it will display positive number. If it is a negative, then it will display negative on the screen. Let's compile this program, execute this program, and check the output. F7 maybe. Okay. It got hanged. This is the problem with this turbo assembler. I could have used emulator 8086 also. That is also installed in my computer, but since I started with this particular TASM assembler, I'm continuing with it actually. So TASM pp17.asm and the link pp17 and then pp17. So it is a positive number. Let's see what value we stored there. We stored there 897, which is certainly a positive number. But if we store minus 897, then what is the number? Then the number is a negative number, right? And what if we store a 0 there? It will be coming as a positive number. Okay. Okay, positive number. Okay, so now we know how to how to decide whether the given number is a positive number or negative number. Okay, now that is done. So now the next question is, now let's come to solve. Let's try to solve now the original problem. Display the content of a 16-bit signed number in decimal format. Okay, we, and also remember, we already know this part. Like, we know if the number is in like unsigned format, we know how to display it, like how to, get the equivalent string version of that number. So only problem left is now, okay, how to get the value of a signed number. Okay, let's see in terms of a diagram what we want to do first, and once we are clear with the diagram or the logic part, then writing the code will not be a very difficult job. Okay, it got, what is this? Okay, let's see it in the form of a diagram first. What we want to do is, now this number is given. Say for example, a number is given. Okay, then what we will do is, we'll first check if it is a positive number or negative number. I'm just writing the flow chart. Okay, if it is a positive or negative, is positive or negative. So if it is positive, if it is yes, then what we want to do is, if the number is positive, then directly display, like here, display the number. There is no problem. Actually, the number is positive means we already know how to display the number, so we can directly display the number. Okay, but if the number is not positive, okay, it means if the number is negative, then what we have to do is, and see here, this checking, how do we know whether it is positive or negative? Just by looking at the most significant bit. That part we already have seen, right? Now suppose, based on that, we are doing a branching. That is, if it is positive, then we know that we have to display the number as it is on the screen. But if it is negative number, if it is a negative number, then what we have to do is, we have to first take the 2's complement of the number. Take 2's complement of the number. As soon as we take the 2's complement of the number, then we get actually the positive equivalent of that number. Because you see here how this -5 is stored. First, we take the binary of the positive number, then we take the 2's complement. So if we now need to, from the 2's complement, from 2's complement representation, if we want to know the original value, then what we have to do is, again we have to take the 2's complement to get the binary of the positive. Okay, so this is how it is stored. But if we want to know what is this, the positive number, again we have to take the 2's complement, and whatever it is, that will be the binary of the positive number. It means we have to take the 2's complement, and once it is taken, then it is now the positive version of the number, and we can simply display it. Now see, we have written code for this part, for this part, for this part. Only thing that we do not know right now is how to compute the 2's complement of a number. Right now, that is also easy in A086 actually. And for that, to take 2's complement of a number in A086, there is this instruction there, NEG. It is actually negate instruction. It means you can think of it, it negates the number. But ultimately, what this instruction is doing is, this particular instruction takes the 2's complement of the source. Okay, it means if you write, say for example, move ax comma -5, and then if you write negate ax, then what will be the content of ax register here? It will be 00000101. That is, after this instruction, the ax will have actually the value that we have seen, fb. That is 11111011, I guess. Okay, fb. But if after this, if we perform negate ax, that is, if we take the 2's complement of this number, then we are going to get this ax as 5. Okay, so this negate instruction actually takes the 2's complement, or it converts the source to its 2's complement representation. Got it? So here, now see, we know all these different parts actually. We know how to decide whether the number is positive or negative, and we know how to display the positive number on the screen. So if it is positive, then we have to display the number directly. If it is negative, then we have to first take the 2's complement, and then we have to display the number on the screen. So we now know how to display a negative number on the screen. At least we know it in the form of a flowchart. Now let's write it in 8086 program. Now see, already we have written the code for this display, so certainly we just have to write a few lines to to complete this program. Okay, then for that reason, what am I going to do is, from here we're going to see here, already we have done this part, isn't it? If the number is positive or negative, we did that actually. See, we take the number, in AX, we shift it by towards left, and based on the carry, we decide whether it is negative number or whether it is a positive number. In this program, if the number is positive, then we are displaying string 1, and if the number is negative, we are displaying string 2. That is, string 1 is we are displaying positive on the screen, otherwise we are displaying negative on the screen. Okay, but what actually we want to do is we want to now implement this program. That is, if the number is positive, then display the number as it is on the screen, otherwise take 2's complement to, and then you display the content on the screen. So let's see how to do that. See, this display part already we have written in our in our previous part video. That program was pp16.asm. This was the program actually, and here you see what we do is, whatever it is the number, we first declare these two variables, and then whatever it is the number that we store in AX register, and then from here to the end, it actually displays the content of AX on the screen. Okay, so here what we do is, let's first fix this part. So if the number is negative, then what we have to do is, say if the number is negative, we have to take the 2's complement of the number. So if the number is negative, we'll go here, and then we'll not sort of display it on the screen. What we'll do is, we'll take the 2's complement of the number. And how do we take the 2's complement of the number? So first we will be moving the number to AX. See here, since we modified this AX, see, we already have copied number to AX, but we modified AX, right? So for that reason, again, I'm copying the number to AX register. And after that, we want to take the 2's complement of that number. So negate the AX. So now AX is having the 2's complement of the number. Now see, in display version, in display program, you see, whatever it is the number that we want to display, we store it in AX register. Now what we have stored in AX, the the 2's complement version of the number, that is the value of the number. Okay, now done, say. And then if the number is negative, I mean, if there is a carry, it means it's a negative number. And then if it is a negative number, first we will get the 2's complement of the number to get the positive value, and then this value, if we display, we'll get the number actually. But also, if the number is negative, we have to remember that thing because of the sign. If the number is negative, we want to put a negative sign in front of it. So for that reason, in the data segment, let me declare a variable, say for example sign. It's a byte, say, just to remember whether the sign is positive or negative. Say by default it is 0, indicating that the sign is positive. But if we get a negative number, we will be moving to sign the value 1, indicating that the number is a negative number. This is just a flag variable. Okay, like if the value of sign is 0, we'll be interpreting the number is positive number. If the value of sign is 1, we'll be interpreting the number is a negative number. This will be using, the value of this sign will be using to display the symbol, whether we should display the negative symbol in front of the number or not. Okay, so that's the purpose. So if it is the negative number, somehow we are remembering it, whether it is positive or negative, just by changing this value of sign variable to 1, and then we are taking 2's complement of the number in AX register. Now this AX is now ready to send to display unit. So we'll be now calling it, say for example, now jump from here, jump to display unit, say. And display unit I have not written, but I'll be writing it in a moment. Okay, so jump to display unit. If it is negative, then things are set. But what if the number is positive? So in that case, we do not want to display the string on the screen. Rather, what we want to do is, we want to store in AX whatever the number is. So in AX, you just store the number. So you might be thinking, why again am I copying it here? Because we already have copied it there. But for the same reason, because once we copied here, this AX is changed actually. Okay, and that was important to decide whether the number is positive or negative. So if we realize the number is negative, then we will be doing this. But if this condition is false, it means the number is positive. In that case, we'll restore this AX with the original number, and then we will transfer the control to, that is, we have our number in AX. Now it is time to display the number on the screen. So display unit. Okay. Now in display unit, then what code we are going to write? In display unit, we are going to write whatever the code that we wrote in PP16 program. But before there, you see string 1 was in used, and that string 1 was dollar 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 dollar. But here anyhow we are not displaying whether it is positive number or negative number. So these two strings are not of any use anymore. So from here you just copy the variables as it is. Sign is the extra variable that we need here, and after that, what else you need? You don't need anything, and this part is done. Load the effective address of bx to string 1. Okay, and this part we have to do, so I'm copying it from here. And once we decide like what that number is, and then in display unit, first we'll be doing this initial setup. We'll be storing bx to point to the starting address and si to be 0, and then move ax comma number. This line is not needed. This line was like, see, whatever the number you have to store in ax, and then from here all the code represents actually printing the string, converting the number to string and printing it on the screen. So display unit, this is initialization, and one more initialization is uh, this move cx comma 10. In ax already we have that number, so we can repeat the same process. Now if you go through the code, it should make sense. If you have already seen the part 14 video, I guess, then this code will make sense certainly. I'll skip now the explanation of this code, and after that, let's see, when we display the number, display result here, we move cx to si, and we actually sort of display the content of the string on the screen. See, si 0, and then now we compute the string, and then here you display. See, move dx comma bx. Bx is the starting address of the string. We copy it to dx, and then using this interrupt service routine, we display it on the screen. Now this is your display. But here is, okay, let's first see the output up to this point, and then I'll change the code. Okay. Okay. This is the code. Just, you can pause and you can type the video, type the code, or you can, while I was doing the change, you also could have done it that way. But in any situation, you just try to write this code and execute the program. Say, for example, the code is written now. Let's now compile and check. So TASM and 17 and 17. 24050 is coming on the screen. What is our number? Minus 24050. That minus sign is missing. So give it a positive number and execute the program. TASM link the 24050. Whether the number is positive or negative, it is giving us the output almost right, except this sign. And how we can solve that problem? See, already you have remembered the value of this sign, whether it is positive or negative, in this sign variable, right? And that sign variable we have to display here actually. See, here it is displaying the number, like the string version of the number. Okay, then also we have to decide whether we have to display the minus symbol or not. And how do we do that? We first compare the sign, the variable sign, with 1. So if they are equal, jump on equal. If they are equal, sign is equal to 1 means what? When did we set the value of sign to be 1? Whenever we get it as a negative number, right? So it means if sign bit is 1, if the value of the variable sign is 1, then jump on equal, it means we have to display negative symbol. Negate symbol. Okay. But if it is jump on not equal, then we don't have to do anything. It's just like display the string. Okay, now Now, if it is equal, then it will be transferring the control to this part here. Here, what we want to do is we want to display the negate symbol. So for that reason, displaying a character actually. To DL register, we want to move this character. Then to AH register, we want to move this number. And then int 21H to display that particular symbol, on the screen. And then yeah, we could have actually modified the string itself, but that I'll leave as a like sort of exercise for you. What am I doing is I'm displaying the symbol separately, and then I'm displaying the string separately. Okay, but if you want, you can put this negate symbol in the string itself. So that I leave as a sort of exercise. If people try to do that, I guess if people got the point, what am I asking you to do? If you have confusion, you can ask me in the comment section. So display negate symbol, I'll be displaying this minus symbol and on the screen, and after that we are displaying the number. But here, if it is not equal, then display string. And what is this display string? That is, we want to directly display the number, so that's why this display string. So if it is not equal, that is, if sign is equal to 1, then we'll be doing this part extra, and then we'll be displaying the string. And if it is not equal, then we'll skip this portion, and then directly we'll be executing this code. Okay, so that way, I guess our program is almost done. It should give you the output. If you store a negative number there, you should get the output as minus 24050. Whatever it is the number that you'll get it. Say, for example, if I store minus 90, then I'll get minus 90 on the screen as an output. Where is my T-link? Okay, minus 90. If you store, say, plus 90, then you will get a plus 90. Right? Okay. Now, okay, then that's the program. Now the program is working for any number. I mean, if it is a signed number, then also it works. If it is an unsigned number, then also it works. So what we did here is, you see, first we are taking that number to AX. We are shifting the bit representation towards left by 1. Then we know, like, the most significant bit will go to the carry flag. So we are checking the carry flag. If the carry flag is set, it means if the value of the carry flag is 1, it means the number is negative. And in that case, we are remembering the sign, and then we are taking the 2's complement of the original number to get the value of the number. Once we have that value, we pass that value to display unit as it is. Okay, but if the number is not negative, then we don't have to do much actually. You just have to restore the number in AX and then simply pass that number for display. Now this display unit is actually going to construct the string, and at the end, when we display the string, just before displaying the string here, we also have to consider whether we should display the negate sign or not. So how we are going to consider it? If the sign is equal to 1, the value of the variable sign is equal to 1, we'll be displaying the negate symbol. Otherwise, we'll not display it. We'll directly display the number. Okay, guys? So that is how we should write this program. Now, one thing I left for you is that instead of writing these minus symbol, instead of like this minus symbol here, you see this minus symbol is not there in the string. In the string pointed by this BX register, right? So what you can do is you can store this minus symbol itself in the string, and then simply direct the display this string. Okay, and if it is a positive number, the sign in the first place will, from the first place only, you will be storing the number. If it is a negative number, in the first place of this in the first character place, you'll be storing this minus symbol, and then from the next characters onward, you will be storing the actual digits. You got the point? Okay, anyhow, try to do that thing. If you find it difficult, or if you find it confusing, then you can ask me in the comment section. Then most probably I'll be able to help you in that case. Okay. Okay, guys, then that much only in this video. See you guys with some new content in the next video. Till then, have a nice day.